Alright, here we are on page 13 looking to develop the area formula for a trapezoid. First, let's review the area formula for a triangle. Notice when we duplicated that triangle and made it a parallelogram, the base in this example of 8 for the triangle is exactly the same as the base of the parallelogram. A unique thing happens when you perform the same technique with a trapezoid. Notice when you rotate the base of the parallelogram, in this case, is now 10 units long. Right? The base of this trapezoid is 8, and when you rotate it, you actually have to take into account the base, the top base of the trapezoid 2, and add that to the base of the parallelogram. So if you look at an isosceles trapezoid, notice the trapezoid is 1/2 of that parallelogram, and same thing if you made it into a right trapezoid. The area of that trapezoid is 1/2 of the parallelogram. So if we go into our notes here, what you need to notice is in column 2, all those figures are parallelograms. Therefore, we can find the areas by just doing base times height. The important concept, though, is to realize that the base of that parallelogram comes from the two different bases of the trapezoids. The upper base and the lower base. Therefore, the area of this parallelogram is going to be 8 times 3, which equals 24 square units. I'll now repeat this process for the next two parallelograms. So now if we went over to the trapezoids, the areas of each of these trapezoids should be 1/2 of the corresponding parallelogram. So moving to the bottom of our page, let's summarize the general formula. So if you take the trapezoid and duplicate it and rotate, notice you now have a parallelogram whose base is actually the sum of the two bases of the trapezoid. So if I label this figure ABCD, the area of ABCD would follow the formula base times height, because we're dealing with a parallelogram there, and the base would actually be B1 plus B2, and the height is still H. If we then just want to look at the trapezoid shaded in green, labeled ABEF, the area of ABEF, which is the area of a trapezoid, should be 1/2 the result we have from above the parallelogram. Alright, let's look at example 6 on page 14. First realize we have a trapezoid, so we're just going to write down our area of trapezoid formula, which is the sum of the bases times height divided by 2. Now let's look at what quantities we're given. Notice we have base 1, it's called the lower base, 25 centimeters. We have an upper base, 14, but we do not have a height. So you have to resist any temptation to think 13 is the height. Notice 13 is not perpendicular to the upper or lower base, so it is not a height. So what I'm going to do is just draw in the height here. And once I have the height drawn in, I'm going to notice that I have a right triangle given an angle and a hypotenuse, and it's looking for the opposite leg. Therefore, I'm going to use the sine function. So sine of 72 equals height over 13, which means the height is 13 sine 72. At this point, you essentially could just copy this height and paste it into our formula, and we're done. But let's go to our calculator so we can get a sense of how big these numbers are. So first thing I'm going to do is just type in 13 sine 72 so that I have a sense of what the height is. So the height's approximately 12 and 3/10 centimeters. Now I'm going to just type in my area formula here, base plus base times height. Now I'm not going to use a rounded value, I'm going to just copy that height so that I get all the precision. And then remembering to divide by 2, we get to our answer. So altogether, the area of this trapezoid is 241.1 square centimeters.